Hey everyone, in this video, I'm going to go over the LeetCode problem, maximum depth of binary tree. So first, let's read the question. Given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. And first, let me just go over some terminology. So a binary tree is a tree where each node can have at most 2 children. So for example, here, right, you can see that this node 3 has 2 children, 9 and 20. 9 has no children, which is fine, but 20 has 2 children, 50 and 7. And then 50 and 7 both have no children, again, which is fine. So binary tree is a tree where at most, where each node can have at most 2 children. They can have no children, or 1 children, or 2 children, but they can't go beyond 2 children. The root node is like the root node is the node at the topmost node. So for example, in this case, 3 is the root node. It's the topmost node. And a leaf node is a node that has no children. So 9, 15, and 7, these are leaf nodes because they have no children. So if you look at this example, right, we see that the maximum depth is 3 because either this path, 3, 20, 15, or 3, 27, has 3 nodes along the path. So how I'm going to solve this issue is by doing something called breadth first search, or BFS. So breadth first search. And what breadth first search is, it's like you traverse the tree level by level. So you start at the root. You go through all nodes in that level. There's only one, which is the root. And then if that node has any children, you go down to the next level, traverse all the nodes in that level, and then just keep repeating. So there's a couple of ways to implement BFS. One way is recursively, another way is iteratively. I myself don't like recursion very much. I prefer to do the iterative approach, so that's what we'll be doing. And so to do the iterative approach, we need a couple of items. We need a queue. And this queue is going to be an array that's initialized with the root only. And then we have a variable called max depth, or MD, as I'll abbreviate it to be. And this variable is going to keep track of the maximum depth of the tree, and this is what's going to be returned. And we initialize it to 0. And we also have a temp variable, which is just an empty array for now. So here's the plan. We use BFS to traverse the tree level by level. And how we're going to do it is this. The queue will represent the number, so the queue will represent the nodes at each particular level. So right now, at the beginning, it's initialized to the root. So for example, if we let's use a tree from the example. So we can see here we have different levels, right? We have this is the first level, this is the second level, and this is the third level. So this queue will store all the nodes of each level. And of course, it's going to be different. The queue will store each node of the current level that's on. So right now we're at the first level, so it's going to store 0. And what we're going to do is, while there's elements in the queue, we're going to keep popping. We're going to keep popping the first node for the first element from the queue. And if that element has any children, like a left child or right child or both, we're going to add the children to the temp array. And once the queue is empty, that means that we've gone through every single node on that level. We're going to increment max depth by 1. And then we're going to do a hard copy from temp to Q. So after Q is empty, Q is gonna copy the contents of temp, and then temp will be cleared. So basically, what temp does is temp stores the next level's nodes. So Q stores the nodes of the current level. Temp will store the nodes of the next level, and when both temp and Q are empty, that's when we know that we've traversed the entire tree. So let me just write like some pseudocode. So here, right? So we're gonna keep looping through Q until it's empty. So here, right? So here we're gonna pop the first element of Q, and so if this node that we just popped, if it has a left child, we're going to add a left child to temp. And if it has a right child, we're going to append that right child to temp as well. Oops, the code. And finally, if Q is empty, so if Q is empty, this means that we've traversed all the nodes along this level. We're gonna increment max depth by 1, and then, oops, so we're gonna increment max depth by 1, and then we're gonna Q is going to become Q is gonna copy over the contents of temp, and then temp will be cleared out. And again, this should be a hard copy. So like I mentioned before, right? Q will store the nodes of the current level, and then temp will store the nodes of the next level. And so at the very end, when both temp and Q are empty, because there'll be a point when there's gonna be a point when the nodes don't have any children, right? Like the leaf nodes, and so temp will be empty. And then when we do this hard copy here, because temp is empty, Q is also empty. And so this for loop will exit. And then at the end, we're going to return max depth. There is one edge case though. What happens if there's no nodes in a tree? So essentially there's no tree. Well, that's a very, very easy thing to check. And here's how to check. So this is so if the root is empty, or like if there's no root at all, if it's none, that means there's no tree, because the root is the first node in a tree. And so if there's no root, there's no tree. And in that case, the depth of the tree is just 0. So and that's just the edge case. So let me go back to the code, and you can see this is exactly what I'm doing here, right? So here, this is for the edge case where there's no tree. Like I mentioned before, right? The root is the first node in a tree. If there's no root, there's no tree. So if the root is none, we return 0. Here we have our max depth, which is used to store like the maximum depth of the tree. It's initialized to 0. We have a queue and a temp. And so here, right, this part, while the queue has elements in it, we're gonna keep popping. We're gonna keep popping the first element from the queue. If that node or the element that we just popped has a left child, we append the left child to temp. If it has a right child, we append the right child to temp. And if the queue is empty, that means that we've traversed through all the nodes on that level. We're going to increment max depth by 1. We're going to do a hard copy from temp to queue. So now queue now has the contents of temp, and then we're going to clear temp so that it can be used for the next level. And finally, there's going to be a point when temp is empty, and that's when we have all the leaf nodes, right? Because the leaf nodes have no children, these two if statements won't like the pens won't work, and so temp will be empty. And then when queue copies temp, it's going to be empty, and so we're going to break from this while loop. We're going to return max depth. So let me return this. So let me submit this. And yeah, you can see this is a valid solution. And yeah, so this is how BFS works, and this is how you do this problem. Thank you all for watching.